Good morning, and a very warm welcome to day 2 here at Apex, and of course Galbraith in Conversation. The topic today is AOI. AOI inspection companies continue to refine their systems using AI and increasingly improving camera technologies. The latest systems are already checking the operator's homework against past decisions to make sure nothing escapes. What should we expect from the future? Here to discuss this today, we have a very eminent panel. To my extreme left, we have Cleve Williams from Saki. Next to him, we have Juan Arango from Parmi. Parmi this week, yeah. Then we have Brian D'Amico from Mirtec, and of course, and Joel Scutchfield from Co-Young. So thank you, gentlemen, for coming in, and let's get started with the first question. And I'll start with you in the end there, Cleve. What technological improvements are we likely to see in the next gen of AOI systems?
Well, as everything is getting smaller, obviously there's going to be camera improvements in the projectors for 3D AOI, more projectors, but most of what the improvements will be is really in the software.
Yep.
A lot more. AI is really in its infancy in AOI, and we're just scratching the surface of what is possible with it. So there's going to be a lot of new features, improvements on existing features to really minimize the need for the operator or the technician or the programmer to spend as much time to run the equipment.
Right. So a lot of software assists on the software to reduce the amount of time that the operator has to be involved in the process.
Exactly.
Juan, would you?
Well, the other thing that it will do is by using the AI, you're going to get more consistency in the programming, because if I program and you program, we may have different ways of doing it.
Right.
And by getting that consistency, the programs will improve. And then if you go into, we all have a second judgment.
Right.
And we're applying AI to that as well. So it's completely consistent. Then it closes loop with the program, because in our world, you want to minimize false calls, but you don't want an escape.
That's true. That's true.
That's the sin.
Anything to add to that, Brian?
Yeah, well, speaking for Mirtec, we just recently introduced our ARC Precision 3D AOI system. And this machine uses 5 cameras, 95 megapixels worth of camera.
Wow.
In order to analyze in 3D. All these cameras are collecting 3D. And we're looking at that with 12 projections as well. So the whole goal here is to take and collect as much accurate data as possible. So, of course, the software is going to be improved as well. Of course, we're introducing AOI and improving that. However, when we start talking about hardware technology, there's a lot of room for improvement there as well.
Right.
Most of the industry uses a single camera for collecting 3D information. By using 5, we're able to cut down on data loss due to blind spots and due to reflectivity, right? Spectral reflectivity.
Right.
So if you're talking about like automotive, it's like life or death. That board has got to be working properly.
Right.
So it's important to inspect it very well once it's inside the system.
Yeah, but I mean, using that amount of camera technology and data capture, that's a lot of data to crunch.
Yeah, it certainly is.
Yeah.
One of the things that we've introduced is what's called CXP2. So that jumps the frame rate up from 90 megabits per second, 90 frames per second to 204 frames per second. So by implementing new optics technology, transfer rates can also be improved.
Yeah.
You got it. The whole goal is this. Most of the systems out there, they will filter the information that comes into the machine to make the images look good, which is important.
Right.
But that filtration really does water down the results of the system, and that's critical. Like I said, automotive, that's critical.
Raw data, to be honest. Yeah.
Absolutely.
Yeah. Okay. Joe.
Just to sum it up, I think everyone is absolutely spot on the hardware side. I see a trend toward larger megapixel count cameras. Basically, ability to gather more information quickly and handle larger boards. The hyperscaling effort right now is demanding that bigger, heavier, and faster. Right. So, but still, as Cleve said, smaller parts. So we have to be able to do all of it. On the AI front, I think it's just continuing to drive towards the lights out initiative, and
Right.
whether we get there or not, and it's really going then beyond what we do independently within our own ecosystem, but again, sharing and allowing the entire process, the entire line to benefit from the results that we're providing to accentuate that lights out initiative, right, to push forward toward it.
Well, that kind of runs into my second question, so I'll stick on you for the meantime, Joel, and that is, how will AI and machine learning change the way that AOI systems detect defects and reduce false positives and adopt to new board designs in real time?
Wow, that's a loaded question, right? So, well, I don't think I have a whole lot of time, but I'm gonna do my best in a very short period. And again, I'm gonna remain a bit general here because, as Cleve said, we're really just getting started with AI, and I think we're each exploring, what those possibilities really are. And again, if we stay focused on using the data the best we can to both maximize the effort that and results that we each independently provide, and then with an eye on the fact that information has to be shared, has to be utilized up and down the line. I think the possibilities are endless, and there's obviously very specific things that can be done. Again, smart review, how we're basically going to use information to feedback to auto program adjustment, so we're not calling things that don't need to be called, et cetera, et cetera. The reduction of the human element on all phases of either review, programming, et cetera, and then moving that information down the line. So so our partners can also benefit in the same ways.
Yeah, no, you're right. I mean, Brian, auto programming's obviously made a big difference to the industry. How do you see AI, developing to help the?
Sure. I see the first major thing here that AI really does is, well, the whole purpose of a machine is you take the board, you put it into the AOI system, it comes back, it produces anomalies. There's a list of anomalies. And so that's the primary inspection. The secondary inspection is typically done by the operator or the rework person. That person's going to look at that and determine what the defects, whether it's a defect or not, and make those classifications. As far as the AI goes, that goes into a large database, like a classification database. And that's really what's used to now find those defects in the primary stage, which is in the machine. So by growing that big data database of defect classifications by things that the machine has seen and the operator has intervened with, like that human-machine interface, by growing that database, that cuts down on false calls, and that makes those defects so that they're caught by the system itself. It takes that burden off of the operator.
Right. Now, Juan, as I said in the opening statement, I mean, the systems are now getting to the point where they're marking each other's homework, or marking the operator's homework. So they're looking, they're getting closer to the agentic AI side, where they're essentially looking at the operator's behavior, what he's called out before as a false call. Maybe a month later, he's doing the same board and he's made a different decision, and it calls it out on that. But I mean, how accurate is that going to be? Is that going to be, every operator's different. One's going to call one thing out as a false call, and the next guy who's got the same experience working on the same board is going to make a different decision. How's that going to work?
So how Parmi's doing it is we handle the auto programming because it all starts there.
Yeah.
A little different. When we deliver the machine, we don't have a database. It gets built through AI, and we just basically start from nothing to build it. And then when you run the program, and this show, we've had customers bring their boards, and if it takes us 5 minutes to program a board, we did something wrong. So it's been quite well received.
Okay.
But then when it goes to the AI verification, that will do a judgment. The good is good. We're not arguing that one. It's the one that for now we'll call a false. Is the false bad or good? The AI prejudges that, and what it can't, then we need a second judgment. but we're able to reduce that second judgment by over 80%.
Right.
So by doing that, and it's got deep learning engine in the background, and it's got SPC analysis as well, very little second judgment is needed, but then it'll go back and fix the tolerances so those false calls don't show up again. So
Right.
the idea is you won't need a second judgment person.
So is it actually eliminating some of these things that would previously been called out as false calls because it's made the decision already, and it's narrowing down the ones that the operator really has to pay attention to?
Correct. And we all have this, I'll call fine tuning, which is to get to the point where you don't get escapes, but you minimize false calls. And what that engine is doing is minimizing the effort to get to that, great program.
Right. Okay. Cleve, have you got anything to add to how AI is going to develop to help the operators?
Yes, as Juan said, our system also learns based upon what the operator is actually classifying. But I think we might get to the point where the operator is not going to be needed to classify. At that point, what's going to be needed is probably a technician or an engineer to actually verify that the AI is staying smart.
Right.
So I think part of it is just to minimize the resources that we need for the line, to run the line. But at some point, it's probably going to flip back a little bit to where you need someone to verify the AI.
Right. Okay. And taking that forward into the machine space, I mean, how will AI AOI machines integrate more seamlessly into a fully automated Industry 4.0 smart factory?
That's a good question. I think we're all doing communication with various other equipment, whether they're screen printers or pick-and-place machines. That has to continue, and it just because everybody wants to have one spot to look at all their data.
Right.
To really find out where they're successful and where they're not successful. So it's going to continue. Apart from that, it's
going to continue. I think a term I've used over the years has been the AOIs, the eyes and ears on the line, basically. And
as Cleve said, again, we started playing with specific certain partners to develop initially, right? You have to do that. You have to, you have to make it work on a small scale before you can expand. But we're seeing now we are expanding. We're all expanding, and maybe we're not expanding in the way that we first intended with the tools that we created, but there's a subset of capability within that work that's been done that can be applied to other suppliers, right? And so it might not be a situation where someone has set a protocol and everybody's 100% following it, but I think there's creativity that's taking place to allow all of us to expand who we can pass information to, what they can do with it, just through our own means.
Yep.
Obviously, CFX was the intended,
of course,
and I think it still is.
Yep.
But we're not waiting, right?
Yep.
We're trying to move that forward. I think
you've got to try and keep up with what's actually happening in the field.
Whatever the customer needs.
Yeah.
That's the drive. Right?
We all have, I'm going to be bold here and say the same mandate, that we have to play nice with everybody.
Yeah.
We don't pick what mounter they use, what printer they use, or what anything in the line. So we all deliver something that has to play nice in that line. And because of that, we are tasked to be able to communicate, because to get to that level, it can't be an island of technology, right? It's got to be shared, because in the end, what do they want to do? Produce good quality product and find what the root cause of something that is a defect. So because of that, the entire line has to play nice.
Okay, so you're going to have open communication like CFX or whatever, but I mean, are there any occasions where you go into a factory install and you find that they're using something strange and it puts an impediment on your ability to extract the right data to optimize the process.
Yeah, certainly. If some company has like older products or legacy products, certainly, because if it's not set up to be able to handle data coming into it or basically take data out of it, there's going to be an issue.
Right.
But you hit it on the head when you said the AOI machine is the eyes and ears. The AOI and the SPI and the inspection systems are really the only machines in a line that are being used to collect data.
Right.
That data is used then to make decisions within line or to make actions within a line. So feeding back to the screen printer, feeding forward to the pick and place, that's very important. But also even predictive maintenance and stuff. All of that data is all incumbent within the inspection systems, wherever they are in the line. So that's just going to become more and more integrated. And as people find that they're going to be able to take that information and use it, take action with that data, it's going to become more refined and make the process even better. That's just continuing effort. It'll continue to get better and better and better. And those machines out there are going to be able to take and use that data more and more in the future. It's all about efficiency and making the manufacturing process as best as possible.
Yeah, okay. Cleve, let's move back to you with the next question, and that is, can we realistically expect AOI systems to achieve higher inspection speeds without sacrificing defect detection accuracy, especially on complex PCBs and advanced packages?
Well, we never want to compromise the quality, right?
Right.
We always have to find the defects, as we can all agree upon that. We probably will hit a wall at some point. We're not quite there. Hopefully there will be a new technological advance before we hit that wall. But there's a lot of different things we could do, right? We could improve the speed of the cameras. We could increase the field of view size, use faster motors, heavier equipment, right? Because vibration kills every type of inspection equipment that's out there. So there are ways to go faster without compromising quality, but we're working on new technologies before we hit that wall.
Right.
But we probably will hit that wall sometime soon.
Yeah, I mean, the character of some of the electronics we're building nowadays is changing quite a bit, with all these big heavy boards coming in with power devices and all the rest of it. So the inspection requirements are going to obviously change with that as well. What's your view on it, Juan?
So I agree with him that there could be a hitting the wall situation, but I think we're a little far from it.
Yeah.
There's still things that we can all do without sacrificing the quality, because that's what our mandate is, right? We're supposed to find the problems.
Yeah.
Our challenge is everything has a cost. Higher resolution, slower speed. So you have to manage that, and so far I think we all have solutions that meet the needs of the market today, and we're all working on something that will meet the needs of the market tomorrow and beyond.
Okay. Brian?
Well, with Mertec, we manufacture our own cameras. So we just introduced a 65 megapixel camera, and that's 4-micron resolution. We are taking and manufacturing those cameras in the CXP2 as well. So by taking and getting a larger FOV size and a reduction to the resolution of the camera, we're able to see very small devices. That's very important, because that's where the industry's kind of going, right? Everything's getting smaller. But also the FOV, by having a larger FOV and the CXP2 transfer rate of 204 frames per second, that's how we're going to be able to handle that. I don't see that there's going to be a wall. I see that technology is, so far, advancing beyond where we need it to be right now.
Right.
And I see that always continuing to get better and better.
Yeah. Well, I mean, I think it's coming down into, there's a lot of development happening, of course, in the advanced packaging side, and the sizes are getting smaller, and it's getting harder to see some of these things. But different coatings, different finishes, etc. But I think all of you have got machines that are now starting to, that are already in the advanced packaging field or about to be, so I think that's where the frontier is, if you like.
I think the key, though, is it's really the goal is to be able to process as much information simultaneously as you can. So, for instance, the double-sided approach, right? So we're top side, bottom side simultaneously. Now we're picking up speed in that regard, while we're doing all the other things with cameras and process.
So that's optimizing throughput.
I think processing, capture is one piece of it, and we have to be able to do that quickly. And the more of that we can do simultaneously for the entire board, top and bottom, is certainly going to drive that initiative, that speed initiative. But then the processing side, as we've talked about, has to happen the same way, right? And again, that's where I think AI can come in and help us with just continuing to evolve. And I think that's why the feeling is that maybe that end of the line isn't as close as we think it is. There's more we can do.
Yeah, I would agree with that. Okay, Brian, let's start off with you, and this is the last question today, and that is, beyond catching defects, how can AOI systems leverage the massive amount of inspection data for analytics, process improvement, and supply chain insights in the future? What else can you capture apart from just defects?
Well, we kind of touched on that a little bit, right? Because we're capturing the defects, but once again, that information that we're bringing in and that classification that we're doing for the defects is what's really going to allow us to eliminate those defects in the future. That's much needed information, right? As far as predictive maintenance for other machines within the lines, once again, we can get that out of the data that we're continuing to pull from the manufacturing process. So that's just going to end up streamlining the entire manufacturing process, quite frankly.
Right, okay. Juan, do you think, is there anything else that you could add into an AOI system that would help to give more insight into?
I don't think we need to add anything in it. It's how we crunch the data, because we capture everything. So here, Parmi is quite different than everybody else. Everybody uses field of view and things like that, where we use a laser scan.
Right.
So by doing that, how we crunch the data is different, and we do it on the head itself. So we don't need such a powerful computer because we don't have as much data. The laser does the 3D and then the RGB. So that helps us. And we have a CMOS on the head that handles, to your point, 20,000 frames per second.
Right.
So by doing that, then it's just a matter of, like, we have software called Smart On. They all have their own software that is basically what ties everything together. And what you're looking also is for trends.
Right.
Because trends is what helps you fix, what you think will be the future.
Right.
So it's just a matter of being more efficient in how we handle the data.
So is the laser system capturing the images, is that better? Is that better or faster than sort of getting raw data the other way?
Well,
Can I answer that question?
Yeah. Go for it.
I wouldn't say it's better. I would say that we do it differently, and in some applications we may be better or faster, and others we're not. So it's just the way that Parmi, by patenting that laser technology, that's what we use.
Right.
But I think we all make very capable equipment, and it's really the customer's choice which one they feel fits best for their needs.
Well, you obviously did it because you thought it would give you some sort of edge. So I mean.
Well, we think it gives us an edge, but obviously he doesn't.
Absolutely not. Would you expect me to agree with you on that one?
I'm giving you that.
This is called a debate for a reason.
But don't worry, you're entitled to your wrong opinion.
Here we go.
Is really where we need to focus, because, as Juan said, we've all got the SMT piece down for the most part. Now it's advanced packaging, but it's also back end, right?
Yep.
There's other places that we can apply our technology.
That's true. Box build.
Box build, exactly. Still within the board build process.
Yeah.
So I think when we talk about expanding capabilities, because we are getting requests for that, screws, barcodes, all these various non-SMT related inspections that have to be done, aside from the line itself, after reflow, after we come through our AOI, initial AOI inspection, that we're getting a lot of push for. So I think you'll see more of that.
Absolutely. Okay, Cleve, last word to you.
I agree with my colleagues here. It's really about the data and how we use the data.
Right.
When you are able to add in X-ray information from the inspection side as well as we can at Saki, you are able to really see how the entire line flows. As Brian said, from maintenance, you're able to and you're able to allocate the personnel, the limited personnel that every company has right now, and schedule that maintenance. You're able to go in and really modify your stencils, modify your programs, modify your boards even with the data that we collect from the defects. And just make improvements even from a design standpoint of the product that's going out to the customer. Not our customer, but the final customer.
And possibly even feeding that data back and that information back to the designer so that he knows not to make the same mistake the next time.
Exactly.
Yeah. Well, guys, great debate, a lot of fun. Next time I'm going to get these, these big foam hammers you can get.
I'm going to bring my own hammer. You guys can use foam.
Have you ever had a brawl in the middle of one of these interviews?
Not yet, but we're working towards it.
Trevor, we all think we have the best. It doesn't matter what we think. It's what the customer thinks.
You're absolutely right.
That's
Gentlemen, great debate. Thank you very, very much. Shout out to Cleve Williams from Saki, Juan Arango from Parme, Brian D'Amico from Murtec, and of course, Joel Scutchfield from Co-Young. Thank you very much, and thank you to our audience for watching today.
Kaizen is the leading global supplier of award-winning cleaning chemistries for electronics assembly operations. Whether you are cleaning stencils or final assemblies, our global team of cleaning experts is there to help you succeed.